In this lesson 1.13, we're going to multiply fractions, whole numbers, and mixed numbers. Sometimes when we learn about multiplying fractions, the answer can be a bit confusing to us. That's because we're so used to multiplying whole numbers, where the product is always greater than each of the factors. So for example, 5 times 4 is equal to 20. 20 is bigger than both 5 and 4, and that's what we would expect. But when we multiply fractions, we often get a smaller result. Why does this happen? So multiplication of fractions is different than multiplying whole numbers. So in this example, you have a Hershey's chocolate bar, and you break it in half, and you give half to your friend Samira. So Samira gets half, and you get half. Now Samira wants to share the love, and she takes her half, and she breaks it in half and gives half of it to Tom. So Samira share and Tom share. So Tom gets half of the chocolate bar. The word of is a word that tells us to multiply. So half of half means half times half. And when we multiply these two fractions, we multiply the numerators and we multiply the denominators. So Tom is getting a quarter. So half times half is not equal to 1. That's half plus half. When we multiply fractions, we get a smaller result. 1/4 is smaller than a half. And this visual is to help you to see that. So the great thing about multiplying and dividing fractions is you don't have to have a common denominator. So it makes the steps a little bit faster. So what we can do when we have fractions like these, 2/3 times 1/4, we're going to find the product simply by multiplying the numerator times numerator. 2 times 1 is 2, and the denominator by denominator. 3 times 4 is 12. Now remember, we always need to express our answer in lowest terms. So 2/12 is not in lowest terms, so we will need to reduce these fractions, this fraction, down to 1/6. We're going to try some different example questions and look at a couple different methods that you can use for multiplying fractions. Remember that for all the methods we look at and all the types of fractions, we don't need a common denominator. So for method 1, what this method tells us is we can just simply multiply numerator times numerator, denominator times denominator, and then reduce the fraction as needed. So 2 times 4 is 8. 8 times 3 is 24. And then we'll need to reduce this fraction, dividing it by 8. So we'll get a final answer of 1/3 here. So this method is great. There's nothing wrong with it. The second method we recommend because when the numbers get bigger, method 1 sometimes gets a bit more difficult. So we recommend a different method. It's the same thing. We're still going to multiply numerator times numerator, denominator times denominator, but what we are going to do is reducing within the question. So this is called cross-reducing. So cross-reducing takes numbers and makes them easier for us to reduce for our final answer. So we look diagonal. 2 and 3 don't have any common factors, so we can't reduce those two numbers. But 4 and 8 are both divisible by 4. So what we're going to do is we're going to divide them by 4. And I'm just going to show that, but you don't have to show. Usually I just cross it out. 4 divided by 4 is 1. And then we're going to do the same. So you have to divide by the same factor. 8 divided by 4 is 2. So that's cross-reducing. After you cross-reduced, now you multiply numerators times numerators, denominator times denominator. So 2 times 1 is 2 over 2 times 3 is 6. Now in this problem, this is a good one to show. There's no guarantee that cross-reducing will mean you won't have to reduce at the end. Once in a while, this happens where the numbers just work out where they're still not in lowest terms. But the numbers are much easier when you cross-reduce. So I'm going to divide here by 2. So I will get 1/3 as my answer, even though I cross-reduced. I would say about 80 to 90% of the time, if you cross-reduce, you will not have to reduce at the end. So we're going to use method 2 for this example, where we have 2 1/4 times 3 1/3. So now we have mixed numbers. We still don't have to have like denominators. So we're going to go right to step 1, which is changing both of them to improper fractions. So we're going to use our C method to change both of these mixed numbers. So 2 1/4 becomes 9/4 times 3 1/3 becomes 10/3. Now we can reduce the numbers through the cross-reducing. So I'm going to take a look at 9 and 3, and both of these numbers are divisible by 3. So I'm going to divide by 3 and divide by 3. On the other diagonal, 4 and 10, these are both divisible by 2. And there's no problem showing yourself, or you can just cross them out. 4 divided by 2 is 2, and 10 divided by 2 is 5. So we've reduced within the problem. Now we're ready to go to step 3. We multiply our numerators. 3 times 5 is 15. And we multiply our denominators. 2 times 1 is 2. So if you're multiplying mixed numbers, you're going to get an improper fraction as a result almost always. So from there, you will need to simplify. So we're going to change this improper fraction back to a mixed number by dividing up. 2 goes into 15 7 times. That makes 14 with 1 left over. So our final answer here is 7.5. So let's do a few more questions together. We've got a few different types here. We're going to use cross-reducing wherever we can. It makes the numbers much easier to reduce. So number 1, we have 15/8 times 4/25. So let's look to cross-reduce first before multiplying our numerators and denominators. So we have 8 and 4. They're both divisible by 4. Divide by 4. Divide by 4. And then 15 and 25 are both divisible by 5. 15 divided by 5 is 3, and 25 divided by 5 is 5. Now we can multiply our numerators. 3 times 1 is 3, and our denominators, 2 times 5 is 10. You can see that this method is much better, especially without a calculator. Even with a calculator, multiplying 15 times 4, right, you're going to get 60, and then 8 times 25, you're going to get 200. So you'd have to reduce 60 over 200. You would have to reduce that down to 3/10. I personally don't think that's very fun. So the cross-reducing makes it much faster. For number 2, what we have is called chain multiplication. Now, when you work a chain, you have some options. You can do 2 at a time. So for example, you can do the first 2, get an answer, and then multiply it to the third one. Or you can cross-reduce all 3. So I'm going to show that method, but you're going to have to choose which way you want to work a chain. Everybody has different preferences. And remember, because you're multiplying, you can go in any order you want. So that means you can cross-reduce in any order you want. So I'm going to show you a couple ways. So one way is I could look over here at the 3 and the 27, or I could look at the 9 and the 27. So it doesn't matter as long as they're diagonal. You could do it either one of those ways to cross-reduce. I'm going to take the 9 and the 27 just because I want to reduce the biggest numbers I can. So I'm going to divide by 9 and divide 27 by 9, and that gets me to the 3. Now I have a 3 up top and a 3 diagonal. I can divide by 3. So divide by 3, divide by 3. So that's the one way. And then on the other diagonal, I have 11 and 10. That's not going to work at all. But I have a 5 and a 10. So even though they're not next to each other, as long as they are diagonal or across, you can reduce them. So I'm going to divide by 5, and 10 divided by 5 is 2. So that leaves that 11 down in the denominator. That's fine. We're going to multiply now. 1 times 1 times 2 is 2 over 1 times 11 times 1 is 11. So my final result is 2/11. But as I said before, you could multiply two fractions, get an answer, and then multiply to the third. Whatever you feel comfortable with, you will come to the same result, no matter which way you do it. For number 3, we have mixed numbers that need to change to improper fractions before we deal with them. So let's change them first. So 1 1/4 becomes 5/4 times 2 2/5 becomes 12/5. Now we look to cross reduce. I have a 5 and a 5. Beautiful. I can divide them both by 5, getting them both down to 1. And 4 and 12 are both divisible by 4, so divide by 4, and 12 divided by 4 is 3. Multiply your numerators. 1 times 3 is 3, and denominator 1 times 1 is 1. And we want to express this in simplified form, so 3 over 1 is the same thing as just 3. Let's do it again. Number 4. First step, change to improper fractions. Whoa, sorry. You see, I'm getting ahead of myself. The second one is already just a proper fraction, so we don't have to change 1/10. So we're going to change 3 1/3 to 10/3. And just go ahead and multiply that by 1/10. We have a 10 and a 10. Beautiful. We can divide them both by 10. Divide by 10. And now we're ready to multiply. 1 times 1 is 1, and 3 times 1 is 3. Our final answer here is 1/3. So you can give the exercise a try. Exercise 1.13.